Okay, so we're now on our last topic for midterm, so which is about the integration of rational fractions. Rational fractions, so most of the time, so can be integrated. It's either using logarithm, okay? So as long as the difference in the degree of the denominator to that of the numerator is 1, so most of the time that can be integrated using logarithmic or the integral of logarithmic functions. And there are cases that we can use power rule as well. Okay, so for rational fractions. So if it resembles the format for inverse trigo, so we can use the integral of inverse trigo functions as well. So we can either use the substitution approach, whether that is algebraic substitution or trigo substitution. However, if those methods are still not possible to be used. Okay, so for rational fraction, another alternative method will be the integration of rational fractions. So using partial decomposition to partial fractions. Okay, so there are cases that we cannot apply those, at least the three, the power rule, the logarithm, and the inverse trigo. If the three are not applicable, okay, so then we can use the partial fraction or for the rational fractions. So there are cases that it would be possible to use partial fractions, and at the same time we can still use the trigo substitution or the algebraic substitution. Okay. So for the integration of rational fractions, so the thing that we need to cover would be how to decompose a given integrand into its equivalent partial fraction. Okay. Kasi once we've found the equivalent partial fraction, so most of the time, so we can use the three methods. It's either it's logarithm, it's power rule, or it is inverse trigo. Okay. Although there are cases that sometimes we need trigo sum. Okay. So probably for case 4. Pero for case 1 and case 2, or for case 1 and case 2, mostly those are logarithm. Case 3, usually, so we could have the inverse trigo, okay, kasi quadratic na siya, or with the use of logarithm and power rule as well. So ayan, so how do we classify? So which one will be the case to use? Okay. In determining the case to be used, we have to take a look at the denominator of the given rational integrand. Okay, so we have to take a look at the denominator. So once we look at the denominator, so we have to decide, okay, so whether the given denominator is factorable or not. Okay. So once it is factorable, so factor it out, and then that's the time that we can classify what case will it fall. Okay. So for example, this one. So usually this is not given as x times x plus 2. So what would be given there would be x squared plus 2x. Okay. And then looking at the denominator here is, what would be the degree of the denominator? So that would be a second degree. So that would make it a quadratic. Right? So that would make it quadratic without factoring. Okay. But then, so after factoring, so we'll be given there as a product of x times x plus 2. So in this case, so we need to take a look at the each factor. Okay. So each factor will tell us whether what case will the factor be under. Okay. So whether that would be case 1, case 2, case 3, or case 4. So when we say case 1 and case 2 pertains to linear. Okay. So case 1 and case 2 pertains to linear factors. Case 3 and case 4 pertains to quadratic factors. Okay. For the difference between case 1 and case 2, one is non-repeating, the other is repeating. So for case 3 is non-repeating, case 4 is repeating quadratic. So that's how to distinguish. Okay, so when we say partial decomposition, this is what I'm referring with partial decomposition. So we are going to decompose to its equivalent partial fraction. So how to do that is, so the first thing is we need to take a look at the factors, and then the number of factors will determine the number of terms for non-repeating. Okay? So for example, in this case, we have two factors. One is x, the other is x plus 2. So we'll be given two terms. So one will be x, the other is x plus 2. So we're going to separate. Okay, so x and then the other is x plus 2. And then since this is linear, so I'm just going to add a at the numerator and then b at the denominator. So that is for linear. So for example, if I will have the 2x plus 1, so all over x times x plus 1 times x minus 2. So for this particular case, so there are three factors, right? So the x plus 1, and then x minus 2. I'm going to write first the x, the second factor is x plus 1, and then the third factor is x minus 2. So those are the three factors. And then all of them are linear. Yeah? So I said this is x raised to 1, x raised to 1, x raised to 1. All of those are linear. So I'm just going to write letter A, B, and C. So A, B, and C here are constants. Okay? So constants yung A, B, and C. So that is what we are going to get later on. What would be the exact value of A, B, and C? So for us to determine the equivalent partial fraction. Okay, so that is on how to use case 1. Okay, so that's for the case 1. So when we say case 2, so this example is case 2. Okay, so x squared all over x minus 1 raised to 2. So remember that x minus 1 raised to 2, it's the same as x minus 1 times x minus 1. Okay, so x minus 1 times x minus 1. So what happens? So there are two factors, so which are both linear, x minus 1 and x minus 1. However, it repeats. So x minus 1 is just the same as x minus 1. So therefore, there's a repetition. So that makes it linear repeating. So how do we write? Okay, its equivalent partial fraction. So we start with the first linear factor, which is x minus 1. And then afterwards, I'll proceed with x minus 1. But this time, I'm going to raise it to 2. So depending on what or how many times it repeated. For example, if I will have 2x all over x minus 3 raised to 3. So again, so this is linear, but it repeats 3 times. So since it repeats 3 times, I'm going to write x minus 3 times as well. X minus 3, x minus 3, x minus 3. But then, so I need to differentiate one from the other. So the first one is raised to 1, the second is raised to 2, the third one is raised to 3. But then x minus 3 is linear. So it's still linear, this is still linear, this is still linear. So that's why the numerator would be A, B, and then C. Okay, so that is for case 1 and case 2. Both are linear. One is non-repeating, case 2 is repeating. Question? So very good so far. So the next one will be case 3. So for if, sir, yung may cube po ba yung repeating? Yes. Repeating can be seen. So if we have a certain function and then raise it to a certain exponent. So because of this 3, that makes it repeating. X minus 3 is repeated 3 times. Right? So it's the same as this, x minus 1 raised to 2. X minus 1 is repeated 2 times. That makes it repeating. X minus 1 is linear. X minus 3 is linear as well. Okay, so this one is case 1. This is case 2. There are cases that it's a combination of case 1 and case 2. Okay. So in cases that the denominator it's no longer factorable. For example, x squared, this one, x squared plus 6x plus 13. So x squared plus 6x plus 13 is not factorable. However, because of the presence of x squared, so that makes it quadratic. Okay, so for quadratic, if the denominator is quadratic, okay, the format of the numerator will be this one. So I need to have, I'll start with a, and then this one is the derivative of the denominator with respect to x. Look at this. So ano ba derivative ng ax squared? So a is constant. So that would just be 2ax. Ang bx naman, b is constant. Derivative niya is b. So that's why we have 2ax plus b. So similar with this, the derivative of x squared, it's 2x. Derivative of 6x, it's 6. That's why we have 2x plus 6 there. Then we'll multiply it with a, and then we plus it with b. So pag quadratic siya, dalawa yung letters niya. Pag linear, isa lang. Pag quadratic, we'll have a multiplied with the derivative of the denominator plus b. Okay. So example, let's say I have 3x minus 1 all over so x squared plus 2. Okay, so we have 3x minus 1 all over x squared plus 2. So there are two factors here. One is x, and then the other one is x squared plus 2. So x squared plus 2 is no longer factorable. Okay, so x squared plus 2 cannot be factored out. So nor x. So therefore, what makes this one? So this one is case 1, because that is linear, non-repeating. I did not repeat. So linear, non-repeating. So I'm going to write here as a. How about x squared plus 2? X squared is quadratic. X squared plus 2 is quadratic. But is it repeating or non-repeating? It's non-repeating because it doesn't have any external exponent. Okay, so therefore, I'm going to make this one as case 3. So case 3 naman to. But then I need to find what's the derivative of 2x or x squared. So its derivative will be 2x. So to write the numerator then, so a na yon, so mag-start na ako sa b dito. B, and multiply it with the derivative of the denominator, which is 2x plus c. So a all over x plus b times the derivative of the denominator plus c all over x squared plus 2. So that's how we write the denominator or the partial fraction equivalent. And the last one, if it is repeating. So if it repeats, so the same as case 2. Okay. So we repeat the denominator, and then afterwards the numerator will be, there are two constants. So one is multiplied with the derivative. So example, I have 2x squared, that's minus 1 over x squared plus x minus 1 squared. Say we have this one, 2x squared minus 1 over x squared plus x minus 1. So we have two factors here, right? So we have x squared and x squared plus x minus 1 squared. So those are the two factors. However, what case is x squared? What do you think is the case for x squared? Is it quadratic, case 3? Or is it linear, repeating, case 2? So x squared, okay? So x squared is actually a product of x and an x, right? So it appears that x it's the same as x times x. So similar with this one, that this is the same as x squared plus x minus 1 times x squared plus x minus 1. So therefore, this is linear repeating. These two are quadratic repeating. So that makes this one, first set would be case 2, and then the second set would be case 4. So x squared is the same as x and x. So that makes it repeating. And then x is linear. X squared plus x minus 1 is quadratic. Then it repeats. So that makes it case 4. So therefore, this would make it x. And this should be x. And the other one would be x squared. And the next one would be x squared plus x minus 1. And then the next one would be x squared plus x minus 1 squared. How about the numerator? So since this is linear, case 1, this is just a, this is just b. Then what's the derivative of x squared plus x? It is 2x plus 1. Right? So that makes it c times 2x plus 1 plus d. And in here, that would be e times 2x plus 1 plus f. Okay? So that's how we classify the cases. So that's just the first step. Okay, so in the integration process. Question? Okay, so we can better understand this. Okay, so once we proceed with the examples. Although I think I can only finish 3 examples for this meeting. And then the remaining 4 examples, I'll be providing you another part 2, or it's part 2 of the discussion. So it will just be a recorded discussion because supposedly we should meet last Wednesday. Okay? So that's why we are behind right now. Sir, maging case 3 po ba siya if may plus 2? What do you mean? Where is plus 2? Ito ba yun? Yung x plus 2 square? Did I get your... Is this what you are referring? Ito yung x squared. Ito. So magiging x plus 2 square. Tama ba pagkaintindi ko? Yeah, Eric. Or you mean another thing? Kasi kung maging 2 square plus 2 square plus 2. 2 square plus 2. Naging 2 square plus 2. Sorry, I don't know. It's 2x square plus 2. X squared plus 2. Okay. Yeah, if it is x squared plus 2, yeah, it will become case 3. So yung tinitingnan natin ito, yung base. So x squared plus 2, it will become case 3. Kasi quadratic na siya nun. Okay, so let's have first example. So for the first example, so we have the denominator, which is x squared minus 4. Question, is x squared minus 4 factorable or not? What's the factor of x squared minus 4? Can we factor it out? So if we cannot factor that out, this will be case 3. It's a quadratic non-repeating, di ba? But then, is it factorable? Yes or no? Actually, it is. It is factorable. So what's a factor of x squared minus 4? Anyone? That's a factor of x squared minus 4.
Difference of two squares, sir.
Okay, so for the difference of two squares, yeah, right. So sa amin, difference lang siya ng square root nila, di ba? Which is x and x minus 2 and x plus 2. Right? So that's why in solving this, we really need factoring. Okay? So if you were not able to identify the factor of the given integrand, that's it. So you can no longer answer it anymore. Okay? So since this is factorable, so I'm going to decompose it. Okay, so it's equivalent partial fraction. So x minus 2 and x plus 2. So I'll start with the first factor, which is x minus 2. The second factor is x plus 2. And we write, so since this is case 1, right? Linear, and at the same time, it's non-repeating. So therefore, I'll just have A there, and I'll have B here. And afterwards, I'm going to transform this one into or free from fractions. Okay? So to free this up from fraction, I'm going to multiply everything by the denominator. Kung ano man ito. I'll multiply it by x minus 2 and then x plus 2. So once I multiply that, so cancel lang yung dalawa. So ano matira? It's 1. Then for the second one, so multiply the A. So what happens? So x minus 2, I'll have A, multiply it with x plus 2 na lang matira. And then lastly, so for B, this is x plus 2. X plus 2 will be cancelled out. So therefore, I'll have B multiply it with x minus 2. Okay, so this time around, so we have the equivalent equation. So we have the equivalent working equation, okay, so without a fraction. So actually, our objective here, so this one, so since we cannot integrate right away, although we can use probably trigo substitution here, but then alternative method would be this one. Ang gagawin lang natin dito is, so since this is equivalent to A all over x minus 2, and then plus B all over x plus 2, then multiply it with dx. But the thing here is A and B are constants. So we just need to figure out, so what is A and what is B, so that we can easily integrate it right away. Kasi this one is equivalent to this. These are just the same. So it's just a matter of knowing what is A and what is B. And then there are two ways on how to do that. Okay, so on how to determine the value of A and B. So the first one is by substitution. The other one is by equation. Okay, so we equate. We substitute. The other one is we equate. So we'll start with the substitution. So for the substitution is we assume. Okay, so we assume value of x so as to determine either A or B. Like for example, there are only two values that we want to get, the values of A and B. Okay, so the values of A and B. But then I want to get first the value of A. So for me to get the value of A, I want to eliminate B. So dapat matanggal muna yung B. So para matanggal ang B, so dapat this x minus 2 should be equal to 0. So what should be substituted to x? So to make the x minus 2 equal to 0. So what
2,
should
sir.
be substituted? Okay, very good. So we're going to assume that x should be equal to 2. Kasi nga, so once I substituted x equals to 2, so I'll have 1 is equals to A. So x plus 2, so 2 plus 2. And the other one is plus B, 2 minus 2. So 1 then would be equal to A, 2 plus 2 will be 4. And then 2 minus 2 is 0. So therefore, I now have A to be equivalent to 1/4. Right? So A is 1/4. So similarly, so for me to get the value of B, so I want to make this x plus 2 should be 0. So to make x plus 2 0, so x should be equal to -2. Very good. -2. So that would make it 1 is equals to A. Okay, so -2 plus 2, then plus B, -2 minus 2. So -2 plus 2 is 0. So that will give me 1 is equals to B times -4. So therefore, B is -1/4. So now we have the value of A and B. So we just substitute it, then we get the new integrand, the equivalent partial fraction for the integrand. But then as I mentioned, there is another way on how to do it. Okay? So let's try to do the other way. So the other way is we're not going to think of any arbitrary values for A or for values of X, I mean. So rather, we're going to equate. So when we equate coefficient Okay? So a coefficient involving certain variable or involving the coefficient of a certain variable. So the first one is we can equate the coefficient for variables involving x. So this actually is the same as these. So ito I'm going to distribute. So I'll have ax plus a times 2, it's 2a. Then plus bx, then b times negative 2 will have negative 2b. So 1 is equals to ax plus 2a plus bx minus 2b. So when I say coefficient of those terms involving x, so I'm just referring to these, the ax and bx. Okay, so those terms involves x, the others do not. Okay, so therefore, so the equation that I will be forming here at the left hand side, so there's no term involving x, so it will just be 0. At the right hand side, so what's the coefficient that involves x? So the first one is a, the second one is b. So a plus b. So this one will become my equation 1. I have 0 is equals to a plus b. So for since there are two values that I need to determine, a and b, I need another equation. Okay, right? I need another equation. So the other equation then so can be taken so by equating all the terms involving constant. So what are all the terms that involves constant? So 1 is constant. Diba? A and B are constant. So therefore 2A is constant, 2B is constant as well. So those are all the constants. And then we equate them. So that makes it 1 is equals to positive 2A. And then I'll have negative 2B. So 1 is equals to 2A minus 2B. I now have equation 2. Equation 1 and then equation 2. And I can do the elimination method. Yeah. I can do the elimination method, or if you want, you can use substitution method as well. But I want to use elimination. So for elimination method, what I'll be doing is I'm going to multiply 2 to equation 1. So para may ma-eliminate ako doon. Sabi sabihin nun, yung 0 is equals to a plus b, I'm going to multiply it by 2. So 0 times 2 is 0. So a times 2 it's 2a. B times 2 it's 2b. And then I'm going to use the equation number 2, which is 1 is equals to 2a minus 2b. I'm going to add the 2. So 0 plus 1 is 1. So 2a plus 2a it's 4a. So 2b minus 2b, 0. So therefore, what is a? A is 1/4. This 1/4, this is 1/4, it's the same. And now that we have that, so we can simply use substitution. Sabi natin that 0 is equals to a plus b. So therefore, what is b? So b is the same as negative a. Right? So therefore, a is 1/4. So b is negative 1/4. This is negative 1/4. This is negative 1/4. So a is 1/4, b is negative 1/4. So now that we know what is a and what is b, so I can now use this one. Kasi this is the equivalent partial fraction of the original integrand. So I'm going to substitute a. So a is positive 1/4. Right? So it's 1/4 over x minus 2. And then b is negative 1/4. Negative 1/4 over x plus 2 dx. I'll just move out the constant, so 1/4, and then I'll have dx over x minus 2. And minus 1/4, the integral of dx over x plus 2. So this time, so we can easily integrate this. Okay, so x minus 2, its derivative, it's dx. So that makes it logarithm, natural logarithm. So this one would become 1/4 and then ln of x minus 2. And minus 1/4 ln of x plus 2 plus c. So that makes it, that's the final answer then. Question. So that is partial fraction, integration by partial fraction. Everything's clear? Okay, so we'll proceed with our second example. So for our second example, although we can see a cube there, so we can factor out x cubed minus x. So we can factor out x there. So that makes it x squared, then x minus 1. So x times x squared minus 1. And for numerator is x squared plus x minus 1. Divide with dx. But then x squared minus 1 is factorable again. I need to factor it out again, so that would make it equal to x squared plus x minus 1. So divide it with x. So factor of x squared minus 1 is again is x minus 1 and x plus 1 dx. So those are the three factors. So therefore, so it's equivalent partial fraction then, so will be, so I'll have x here, so plus x minus 1 and plus x plus 1. Then all of those are linear. This is linear, x minus 1 is linear, x plus 1 is linear, dx. So therefore, it's still case 1. Okay, so this is still case 1. So we just need to find out, so what is A, B, and C? So A, B, and C, this is the same as x squared plus x minus 1 all over, so x times x minus 1 times x plus 1. So will be A all over x plus B all over x minus 1 and plus C all over x plus 1. So we multiply everything by x, x minus 1, x plus 1. For the first term, to the left-hand side, so cancel lang yung sa denominator, so matira yung numerator. And for A, so we cancel out x, so we'll retain x minus 1 and x plus 1. For B, so we remove x minus 1, so we'll just have x and x plus 1. Then for C, so we remove x plus 1, so we just have x and x minus 1. So that's our working equation. Okay, so again, it will be easier for us to do some substitution. Again, so in deciding, so what will be the value of x? Okay, again, we have to take note. So what are we eliminating? So for example, so we eliminate B and C. Okay, so for us to get the value of A, so we should be able to eliminate B and C at the same time. So how do we eliminate B and C at the same time? So we have to take a look at the common factor. Ano yung common sa B at saka sa C? In this case, what is common is x. Parehas silang may x. So therefore, what should be the value of x? So to make B and C 0. So x should be, what should be the value of x? So to make B and C 0. It should be 0. Okay, very good. So 0, di ba? Pag nag-0 na to, 0, multiply mo na yun. 0 na lahat ng B, 0 na lahat ng C. Okay? So that would give us, so 0 square, mental na lang to. So 0 square, 0, plus 0, then minus 1. Then A, so 0 minus 1, it's negative 1. Tapos 0 plus 1, it's 1. So B is 0, C is 0. So therefore, what is A? A then will be negative 1 over negative 1, positive 1. So we have the value of A. So next, so I eliminate A and C. So what is common to both? X minus 1, X minus 1. So I want to make that 0, the X minus 1, so therefore X should be 1. Because 1 minus 1 will be 0. So eliminating A and C. So ngayon, when X is equals to 1, so that will be 1 squared is 1, then plus 1 minus 1 is equals to, eliminate na yung A, yung B will be X is 1, 1 plus 1 is 2. So 1 minus 1 is 0 plus 1, so this one is 1 is equals to B times 2. So therefore B is 1/2. And lastly, we want to get the value of C. What is common to A and B? It is X plus 1 and X plus 1. So therefore, when X, to make X plus 1, so X should be negative 1. So that would make it, so negative 1 square would be positive 1, then negative 1 minus 1 is equals to, so A and B are 0. So C, negative 1, so negative 1 minus 1, it's negative 2. So 1 minus 1 is 0, I'll have negative 1. So C, positive 2. So therefore C is negative 1/2. I have all of those. So therefore I can now just copy that. So what is A? A is 1. It's 1 all over X. B is 1/2. So plus 1/2. X minus 1. Then minus 1/2. So C is negative 1/2. X plus 1 dx. So that's the same as dx over X plus 1/2 the integral of dx over X minus 1 minus 1/2 the integral of dx over X plus 1. The final answer would be ln of X plus 1/2 ln of X minus 1 and minus 1/2 ln of X plus 1. Let's see. So as you can notice, so for case 1, okay, so for case 1, it's always logarithm. Okay? So logarithm lang yung approach niya. No? Okay? So let's have one more. Unless you have some questions. Okay, so wala. So again, we can finish example number 3. We have x plus 7 over x squared times x plus 2. So remember that x squared, it's the same as x times x. Okay, so that makes it linear. But then linear repeating. We'll have x, and the other one will be x squared. And the last one would be the third term, so which is x plus 2. So linear, again, linear repeating, so it would still just be b. And then this is c. I multiply it with dx. It's partial equivalent x plus 7 all over x squared, so times x plus 2 equals 2. So a all over x, so plus b all over x squared, and plus c all over x plus 2. So we multiply everything by x squared, so times x plus 2. So eliminating the denominator, we'll just have x plus 7. So we have x there, x squared yun doon. So cancel yung x, may matitira pang isang x. I'll have a x times x plus 2. The other one is for b naman. So b, so we eliminate x squared. So we'll just have x plus 2. Lastly, we have c. So we eliminate x plus 2. We'll just have x squared. So now, can we use the substitution method? So let's try to see whether we can use substitution or not. So in getting the value of a, so we have to take a look at b and c. Yeah, so we need to eliminate b and c at the same time. But looking at this, there's nothing common. There's no common factor for b and c. One is x plus 2, the other is x squared. So in that case, so since there's no common to both, so therefore we cannot eliminate b and c just to get the value of a. So if that is the case, we cannot go there. Okay, so we can proceed with the next one. So for the next one, so let's try to get the value of b. So to get the value of b, so we look at a and c. So what is common? This one it has an x, this one it has an x as well. So common si x. So therefore, so we can substitute that when x is equals to 0, so we'll be eliminate a and c. So x is equals to 0. So 0 plus 7, it's 7 is equals to, so a is already 0, so b times, so 0 plus 2, it's 2. So therefore, b is equals to 7 all over 2. So this is our b. And then, so we want to get c. So to get c, so we have a and b. So what is common? It's x plus 2. So the common factor is x plus 2. So therefore, when x will be equal to negative 2, okay, so when x is negative 2, that would make it negative 2 plus 7, that would make it positive 5. So a and b are eliminated. So just have c, negative 2 squared, that would be positive 4. So therefore, c is 5 all over 4. But then, I can no longer find the value of a. Diba? Pero sabi natin, we have another method. So which is by the equation of coefficient. So we can do that one. As I remember, this is the same as x plus 7 is equals to, so I'll distribute ax to x plus 2. That would make it ax squared plus 2ax. The other one is plus bx plus 2b plus cx squared. So usually we equate coefficient involving, tingnan mo yung konti lang. So those coefficient involving x squared, ano yun? This one and this. So dalawa lang. So that makes it, sa left hand side, wala. So that is 0. The right hand side, so we'll have a, and then we have c, a plus c. So we are to find a. So therefore, a is negative c. So a, negative c. C is negative, or it's 5/4, so it would just make it negative 5/4. So we now have the three values for A, B, and C. So in this case, it's a combination. Okay, so you don't have a choice but to use elimination or the equation or through substitution. So we write that our A is negative 5/4 all over x. Our B is 7/2 over x squared. And then our C is 5/4 all over x plus 2 and dx. So we rewrite this one. So this makes it negative 5/4 integral of dx over x. And so we move out 7/2. However, we can make the x squared. So since this is x squared, so I can move it up. So I can use power rule. X negative 2 dx. Then lastly, plus 5/4 the integral of dx over x plus 2. This one is linear, so that's logarithm. But this is quadratic, so we can use the power rule. So we'll have negative 5/4, and this would be ln x, and plus 7/2. Multiply it with x raised to negative 2 plus 1, it's negative 1 over negative 1. So plus 5/4 ln of x plus 2 plus c. So finally, so we'll have negative 5/4 ln of x. Then I'll have a negative 7/2. So x raised to negative 1, baba na lang natin siya. I'll have negative 7/2x. And plus 5/4 ln of x plus 2 plus c. So that makes our final answer for partial fraction. And that's it. So I still have 4 more examples. I'll be discussing that one on a separate video. And that's it for this topic. Let me stop the recording.